Being able to draw Lewis structures is incredibly important in chemistry because, as you can see in my example over here, that it diagrams out what a covalent compound looks like or what a molecule looks like. Once we understand that, we can start to think about things like polarity and will it be a gas at standard temperature and pressure, and how will it interact with other things? And all of that starts with Lewis dot structures. Over the course of the next couple of lessons, so there'll be a series of them, you can look in the description down there. Here's what we're going to learn about Lewis dot structures. I'm going to give you the rules here in this first lesson. Then we're going to get into drawing polyatomic ions with a formal charge. What does that even mean? I don't know, but you will know when you get to that lesson. And Lewis structures for molecules with multiple bonds. So what happens if we have a double or a triple bond? How do we deal with that? And then the last one is Lewis structures of resonance hybrids. We're also going to cover one other one in there, and that's if we have a whole bunch of, like an organic molecule with a whole bunch of carbons in a chain. What do we do with that? So over the course of all these lessons, you're going to learn everything you need to know about Lewis structures. Again, there'll be a list of all these lessons down there in the description. Sometimes you'll hear Lewis dot structures referred to as electron dot structures. I'm going to call them Lewis dot structures because officially a Lewis dot structure is really where we're not just using dots, we're using these lines to represent bonds. So a Lewis dot structure is a structural representation of a molecule where dots, like these right here, are used to show the position of electrons around an atom, and lines are used to represent covalent bonds between atoms or the sharing of electrons. So the dots, do write this down, I would, because it's good to have all this information together so that you know how to draw Lewis structures and you can come back to your notes and look at this. Each dot represents one unshared electron. So over here we can see there's one, there's another. That makes 3, and that'd be 4. There'd be 4 unshared electrons around our water. The line represents 2 shared electrons. That's the definition of a covalent bond. So we've got 2 shared electrons here and 2 here. The hydrogens are making a covalent bond with the with the oxygen to form water. So all we do when we draw a Lewis structure is we place lone pairs, electrons, and lines at right angles. So notice that there aren't really 2 electrons living there. This is just sort of an artistic way to be able to represent where they live, right? Or where they exist on the outside. You must understand valence electrons to be able to draw a Lewis structure. And we've covered this in several lessons earlier. You can find links down there, but I'll go over it very briefly. Remember, each group on the periodic table is grouped up because they have the same number of valence electrons, really because they act like each other. So that first one there is group 1A. The 1 tells us how many valence electrons they have. So in that example right here, hydrogen has how many valence electrons? It has 1 because it's in group 1A. Next group over here, they have 2 valence electrons. I'm going to jump all the way over to the other side of the periodic table over here because these ones are called transition elements. I'll put them up there. But we have 3 valence electrons, 4, 5, 6, 7, and 8 over there in the noble gases, the last one. If you don't know this, do write it down. You're going to need it, well, really through all of your chemistry from here on out. If we get to these, the transition elements, they do have numbers that go with them, but they don't always follow the rules like they should. So we kind of have to be careful with them. I'll show you how to deal with all of that. And if you're unsure what all these Roman numerals mean, this is a 3, a 4, Roman numeral 4, 5, 6, 7, 8, 8, 8. So the V is 5 and each of the lines is 1. This is 1 and this is 2. So for example, manganese, we would expect to have 7 valence electrons, but it might not always have 7 valence electrons because it's a transition metal. Now these ones with the A, we can pretty well expect them to have the number of valence electrons that we're associating with them. So they're a little easier. If you've watched any videos from me in the past, you know that when I give you a set of rules or steps to help solve things, I put a box around that. And I would encourage you, as you write it down, put a box around it in your notes, because if you end up with a whole notebook of notes, it's the ones that have the boxes around them that you're probably going to need to go and refer to over time. Now, I'm going to read this while you write it down, but it's not going to make a lot of sense until we do some examples. So the next several slides are going to have examples for what we're going to do to draw Lewis structures. Now, number 1, we're going to add up the valence electron from all the elements in the molecule. How do we do that? We go back to our periodic table and we just look what group it's in. Now, if it has a formal charge, so I'll bring in each one of these steps as we get more complex. If it has a formal charge, I'll show you how to add or subtract electrons to make it correct. When we're done with that, we're going to build our skeleton structure. Skeleton structure just means the bare bones. It's just where we have the elements and then the bonds between them, but we're not quite done, so we call that a skeleton structure. A quick reference is you're going to have lots of elements and you're trying to decide, where do I put these on my structure? The element with the lowest electronegativity is going to go in the middle. Electronegativity is something that you would look up for an element or its position on the periodic table, again in an earlier lesson. And the element that is least abundant is usually the one that's in the middle for these simple compounds that we're going to start to draw. Number 3, we're going to add electrons around the outside of the molecule. We have to use all the electrons that we added up right up here. I'll show you how to do that. Number 4, if it has a formal charge, okay, we're going to add brackets and we're going to show the charge. If it doesn't have a formal charge, we'll skip this step. Number 5, if it has resonance structures, we will do step 5. If it doesn't, we'll skip that step. And then number 6, I'm always going to encourage you to check your answer, because if you check your answer and you follow these rules, you're going to get them right every single time. Every atom needs to have 8 valence electrons out around it when you're done drawing. Except for hydrogen, helium's not going to really bond with anything, but I put it up there just because people in the past have been like, what about helium? Oh, there you go. Hydrogen's the big one, right? Hydrogen is perfectly fine having 2 valence electrons when it's done bonding. The best way to learn is to do examples. And we're going to start off with chlorine gas. We're going to start off very, very simple and we'll build from here. Chlorine gas, remember, is diatomic. So it's not just Cl, it's Cl2. Now let me show you how we do this. Add up valence electrons for all the elements in the molecule. I'm going to break this up into what it is. I have chlorine and I have 2 of them. I will use this system all the time. So if you're watching my lessons, you're going to see me write this out the exact same way every time. Now I come over and I find chlorine on the periodic table and I see that it's in group 7A. So I'm not going to write the Roman numeral, I'm going to write the number. Group 7A have 7 valence electrons. So here we go. Each one of my chlorine has 7 valence electrons. I use E negative to remind myself that I'm dealing with electrons. There are 2 chlorines right here. There are 2 of them. I'm just transforming this into a math problem. Now I have 7 times 2 equals 14 electrons. So that's adding up my valence electrons to figure out how many I have to build my Lewis structure. Add or subtract electrons to reach a formal charge. I'm going to give you a hint. If there was a negative up here, or if there was a positive up here, or a +2, that's what a formal charge is. But this one doesn't have anything up there, so I don't need to worry about that step. I'm done with number 1. Number 2, build the skeleton structure with the bonds. Well, to build the skeleton structure, I just take the elements, chlorine, and I know I have another chlorine, and I need to show that they are bonded together. That's the whole point, right? Those 2 are bonded together to make a molecule. Now, the lines, if you remember correctly, represent 2 electrons. And this rule right here says I need to add all the electrons, we built the skeleton structure. I need to add all the other remaining electrons around the outside of this till I've used 14. I can't use 13, I can't use 15, it has to be 14. So I've used 2 so far. I'm just going to start to put them around the outside edge. 2, 3, 4, 5, 6, 7, 8. Okay, I've used 8 total, but I need to get to 14. 9, 10, 11, 12, 13, 14. Oh, look at there. I've used up 14 electrons. So let's come down here. I used all of them from step 1. Add brackets if it has a formal charge. Remember, it doesn't have a formal charge. Resonance structures. I won't give you any examples with resonance structures until we've learned that lesson, which will be down in the description if you want to jump ahead to that. And then we always check our answer, right? Everything needs to have 8 electrons around it when I'm done. So let's see. This chlorine has 2, 4, 6, and then this represents 2. So it has 8. This chlorine has 2, 4, 6, and then this represents 2. It also has 8. So there we go. We've just drawn the Lewis structure for chlorine gas. Let's try drawing the Lewis structure for methane together. Here we go. CH4 is methane, 1 carbon and 4 hydrogen. I'm going to add up the valence electrons for everything in this. So I'm going to break it up into its pieces. I know I have 1 carbon, and I do have hydrogen. I have 4 of those. That's what the subscript means right here. And then I'm going to go and find carbon over here on the periodic table. It is in group 4A, so every carbon has 4 valence electrons. I have 1 of them. And I like to say each carbon brings 4 valence electrons to the party, and 1 carbon's coming to our party. So how many valence electrons are the carbons bringing to the party? They're bringing 4. I come over here and find hydrogen, which is in group 1A. So each hydrogen has 1 valence electron, but we have 4 of them showing up at our party. So that's a total of 4 electrons from our hydrogens. We add them up and we get 8 electrons. Remember, formal charge would be if it had a plus or a minus 2 up here. It does not, so I don't need to worry about formal charge. Build the skeleton structure with the bonds. Well, I have carbons and I have hydrogens. So what goes in the middle? Now we have to be careful, because if you look up the electronegativity, hydrogen has a lower electronegativity than carbon. And this general rule says the element with the lowest electronegativity goes in the middle. But hydrogen will never be the middle of anything. Hydrogen only has 2 valence electrons when it's done filling up its outermost shell. So it can only bond to one thing, which means it's not going to be a central atom with a bunch of stuff bonded off of it or branching off of it. So even if hydrogen is the lowest one, it won't be the center, which means for us, our carbon is going to be the center. All right, let's put the carbon in here. And then we're going to bond 4 hydrogens to this. If you remember our rules over there, we bond them at right angles because this is just an artistic representation. I need to put my hydrogens in, so I'll just put them at the end of each one of these bonds. There needs to be 4 hydrogens when I'm done. And then there's my skeleton structure, right? I'm going to add electrons around the outside of the molecule till I've used them all up. Let's count. Our carbon currently has 2, 4, 6, 8 electrons, and that's all the electrons we get to build our structure. So we can't add any more on there, so maybe this is correct. Add brackets, it does not have a formal charge, so we don't need to do that. We have not learned about resonance structures yet, so I haven't given you one with resonance structure. We're going to check our answer. Hydrogen is okay having 2 valence electrons. This one has 2, this one has 2, 2, 2, so all the hydrogens are okay. Carbon has 2, 4, 6, 8. Oh, looky here. Our carbon is full, it is happy, and this is the Lewis structure for methane. Next up, ammonia. I would highly encourage you to pause the video and practice this one on your own. Then you can hit play. You can even fast forward and just check your answer and see if you're doing these correctly, because this is the last example for our introduction. And then the next video, we're going to start to make molecules that are a little more complex. For those of you following along, let's break this up. We have 1 nitrogen in our ammonia, and we have 3 hydrogen. All right. So each nitrogen, I look over here, nitrogen's right there. It's in group 1, 2, 3, 4, 5. Each nitrogen is going to bring 5 valence electrons to the party. We only have 1 here, but that's all right. And each hydrogen right here is in group 1A. They each bring 1 valence electron to our party, but there are 3 of them, so that's a total of what? 5 plus 3 is 8 valence electrons to build our structure. There is no formal charge because there's no positive or minus up here. We're going to build the skeleton structure. Which one goes in the middle? Nitrogen or hydrogen? Well, we said hydrogen will never be the center of anything, and that leaves nitrogen as the only one left. So we're going to put nitrogen in the middle, and we're going to branch 3. Now, I don't know where to put these hydrogens, and for now, it doesn't matter. I just need to put them on there somewhere. We'll get more specific as we progress, but for now, you know, happy little hydrogens, put them wherever you want, as long as they're at right angles to each other and it looks similar to this. It would be okay if I put one up there and didn't put one here. Doesn't matter. There's my skeleton structure. I need to add electrons around the outside of the molecule until I've used them all up. Let's count them. I've used 2, 4, 6, and I need to use 8. So I have 2 more to put on here. I can't put any more on the hydrogen because it already has 2, and hydrogen is full when it has 2 valence electrons. Same with this one, it has 2. This one has 2. Now my nitrogen would like to have 8, right? Right now it has 2, 4, 6. So I must need to put those other 2 electrons here on the nitrogen to fill it up. I've used up all 8 electrons right there. I add brackets if it has a formal charge. It doesn't. And resonance structures, it doesn't have that. And check our answer. Nitrogen right now has 2, 4, 6, 8. Each of our hydrogens have 2. This is the Lewis structure for ammonia. That's the basics for Lewis structures. But if you look at this one next to me here, it's a little more complex, right? This one does have a formal charge. And so in the next set of lessons, we're going to learn how do we deal with something when it has a formal charge? How do we add up its electrons? And you're going to be really great at these. Just look the description down there, and that'll take you to the next video to learn about polyatomic ions and Lewis dot structure. This is me reminding you to keep on learning.